video sits alongside part 6 in my GCSE Science Sprints series of shorts, so I'm just going through the exact same exam questions but in a bit more detail and explaining why I'm doing what I'm doing at each stage. Here we've got a physics question, but really this is more designed to test your math skills than your physics skills. So as you know, in GCSE Science, 20% of the marks are for math skills at an appropriate level, and that's split up into 10% of the biology marks, 20% of the chemistry marks, and 30% of the physics marks. So in this question, we're checking, can you use decimals, can you use significant figures, and also can you change the subject of an equation by rearranging it. So here we're looking at two different Olympic medals, and we're told they have the same cross-sectional area, but as we can see in the table they have different thicknesses and different masses, and we're going to try and work out what the density of the bronze medal is. So first up, let's use the density equation that we know. So density is mass divided by volume, and we're going to rearrange this to try to work out what the volume of the gold coin is. So volume is mass divided by density, therefore the volume of the gold coin is 45.95 something. Now I've stopped writing at this point because I don't want to waste all my time writing a really long number, but of course it's really important that you never round until the very end of your calculation. So just keep using that answer button on your calculator, or if you don't have a calculator that has one of those, then just write out the full calculator display. So now that I know the volume of the gold coin, I want to try and work out the volume of the bronze coin. And as I can see here, I've been told they've got the same cross-sectional area. So the sort of circle bit is the same as each other. I could put one on top of the other and it would cover it completely. But the thickness is different. So the bronze coin is slightly thicker than the gold coin, and therefore its volume is going to be slightly larger. So to work out its volume, I'm going to take the volume of the gold coin, I'm going to divide it by the thickness of the gold coin and multiply it by the thickness of the bronze coin. And that gives us 53.6088 blah 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 centimetres cubed. Do yourself a little common sense check at this point. How have I done it the right way round? If my bronze coin is thicker, then the volume should be higher. Yes, it is, but it's not lots thicker, so it shouldn't be lots higher. Yes, my volume is still kind of approximately the same. I'm not suddenly saying that I've got a volume of 950 or something like that. So now that I know the volume of the bronze coin, I've already got the mass of the bronze coin and I can work out the density. So we've already said that density is mass divided by volume. So 450 divided by 53.6. Again, I wouldn't actually round here. I would use the answer button on my calculator, and I'm getting an answer of 8.39 blah. So again, is that a sensible answer? Is it about the same density as the gold? Is it sort of the same order of magnitude? Yes, so that's going to make sense. And it's a slightly lighter medal in a slightly larger volume, so I am expecting the density to be lower. Now this question has an additional step in that it asks me to give my answer to 3 significant figures. So in that case, I need to look at my answer that I've got right now, and I need to count off the first 3 significant figures, and then it's the 4th significant figure that determines whether I round up or down. So 4 is less than 5, therefore we're rounding down. So my final answer is going to be 8.39 grams per centimetre cubed. Thanks for watching, and I hope you'll be back next week for the next biology one in this series. If you are finding these useful, then don't forget to like, subscribe, comment and share, because all of these help me to grow the channel. I'll be back soon for some more GCSE Science.